What's up, y'all? This is Hussein Nasser from iGeometry, where we discuss software engineering by example. And today's example is actually Instagram, and today's topic is isolation. So, if you haven't watched the list of the series, I recommend watching the read phenomena that we explain, which is dirty read, non-repeatable read, and phantom read. So I'm going to reference them here. So these are the problems that we face while we trying to implement isolation in the database itself. Okay, so I do recommend watching the rest of the series that we did, all right, a few weeks back. And yeah, so what we did here is actually a matrix of the different problems that we face, and we explain each one of them. So dirty read, non-repeatable read, and phantom read. And now we're going to discuss solutions to a database solutions so we can fix and tackle these problems. So the first solution, which is this episode, is in this episode we're going to discuss the first solution, which is not really a solution, but it's just a method of application. I basically do not care about isolation. I do not want any isolation at all. If I am executing a transaction, let people write, step on each other's toes. I don't really care because isolation is expensive. I don't really want to implement it. It's an overhead for me, so I'm not going to do anything about it. So this approach is read uncommitted. It's called read uncommitted. So uh, yeah, let's just write it down here. So read uncommitted. I think it's double T. Yep. So what we're gonna do here is go to our example, an Instagram example, and just try to apply and see if we can reproduce these problems in all of these in this example. Can we, with this approach, reproduce all this? Do we have a dirty read? Do we have non-repeatable read? Do we have a phantom read? So let's go back to our real example here. So most of you, like if you watch these series, we know this as like a similar simulation of Instagram uh, database schema, very basic, right? There's not actually the actual database schema, but you know, just from what we have. So pictures, we have a table called pictures, likes. So who liked what? And that's basically, this is it. So one to many. So we have one picture liked twice, and these are the people who liked this picture. Okay, so we will try to reproduce read uncommitted. Basically, hey, do not isolate anything. Okay, so just execute stuff. Okay, so let's just do the first. Let's try to reproduce dirty read here and see if we can actually reproduce it, right? So a dirty read is if someone tried to write and someone else tries to read a dirty uh, record that has not been committed yet. So let's take an example. Mr. Jon Snow here and Miss Sansa. Sansa, what are you doing? What are you doing, Sansa? What happened here? Oh my god. Come back. Come back, Sansa. Come back. Look at that. Look at that. Okay. Okay. Alright. Alright, it's just different. Let's choose some different colors, so because we're gonna use these different colors to mean different things. Alright. And yeah, why not? Green. Why not? Okay, Jon and Sansa. Alright. So, what Sansa does, she executes a query, alright? Her first transaction. She want to know how many likes, right? So she selects likes count from pictures where ID is equal 1. So she just queries that picture. How many likes does this picture have, right? She want to execute that statement, but before she does that, uh, Jon here is actually executing a like. He's trying to like his picture, but that picture is already liked. So what happens here? So what will happen here, he will try to execute a like. A like is basically an update, increase that, and then insert a like, insert a record in the likes table. So that will be update pictures. Let's make this, which color was that? Yeah. Come on, mate. Okay. Update pictures, set likes count equal likes count plus 1. Okay. And then let's just execute that statement, right? So first thing, it tries to update that. So this becomes 3, but it's not committed, so it's red. Someone touched that, made it 3, so we're here, right? We are here now. Okay, we executed that. Sansa came in. Since we are in the mood of read uncommitted, Sansa is now executing this statement, tries to find how many likes this picture got, and she got, holy man, what the hell? What was that? Can we just copy and paste? So she got 3, basically, right? So she selects that and she got 3, because that's the value right there. It's uncommitted. So what does that mean? It's written, but we're still executing that transaction, so anything can happen here. So while John is trying to execute that statement, is still not done, right? Because the second statement, which comes, too bad, Sansa's caught up between those two statements, and now he's trying to insert a record, right? Insert into likes, values, 1, and John. Which we all know that this query will fail. And the reason is of unique constraint, baby. So that execute will fail because we're trying to insert a record 1 and John, which is our primary key. Maybe I forgot to mention that, but this is the primary key, the composite primary key on the likes table, where you cannot try to insert 1 and John because, hey, it already exists. So that will fail. And guess what? If that statement fails, since we have atomicity in our, sorry about that. So since we have atomicity in our databases here, that atomic transaction will fail, because if one fail, all fails. That's the definition of atomicity here. So that fails. So guess what? This now changes back to 2, to the original value. And now what Sansa have is basically a dirty read, because that was not the accurate representation. Because now if Sansa tried to actually find the list of users, right, who actually likes, she's expecting to have actually what, 3, right? So she would do select all from likes, and guess what? She was gonna get, how many records she's gonna get here? She's gonna get 2. So that's she just end up in an inconsistent state. What she did is a dirty read, right? She just had a dirty read. She read a value that was not committed, that could have changed any time, right? And it changed. It did change. So that read uncommitted is what we just did. We are allowing people to read uncommitted values, right? So yeah. So we know that read uncommitted actually does a dirty read. Okay. Does it do a non-repeatable read? Right? If a non-repeatable read, we can use the same example here. So if now Sansa, she said, okay, in the same transaction again, she said, okay, I'm not gonna query that. Just execute the same query, right? Just execute the same query. Select like count in the same transaction. So Sansa came in here, execute the same query. Guess what? Now she gets 2. It's like, what? It's like, what? How? But I just queried. But I got different results. Alright? So yeah, we do get non-repeatable reads here as well, right? Do we get phantom read? You bet we get. Phantom reads are basically this example will not cover it, but we can quickly do that, right? So how can we get a phantom read? Okay, let's do a phantom read here. Okay, let's just erase all that. Can we get a phantom read here? So we need to change John to somewhere else here to actually can like this picture. Okay, so phantom read. Sansa, Miss Sansa here, what she's gonna do is queries the likes table. She has a picture ID and she want to know who actually liked this picture. So from likes where picture ID is equal to 1. Good, look at that. So she got 2 records in this case, right? She's gonna get John and Sansa herself, but yeah, 2 records, right? At the same time, she's doing other statements in the same transaction, same unit of work. Eddard, her father, saw the wolf picture and attempt to actually like that picture. So he will actually execute update pictures, set likes count equal likes count plus 1. All right. And then what will happen is he'll continue, actually insert the record into the likes table, insert into likes values 1 Eddard. Cool. And then what will happen is Sansa decides after a while come back and requery the same table. Okay, so let's see. Sansa executes, she got Jon and Sansa. Alright, she got 2 records. Eddard updates, so what do we get here, man? We get 3, right? Let's just change it to red so we actually know that's updated. Again, it's uncommitted, but it doesn't matter. Insert into likes values, right? So you insert a new row, which is cool because it's the first time there's no record here that Eddard actually liked this picture. So Eddard, cool. And now we executed that nicely. Now we're gonna execute Sansa again, queries that, and guess what? Now she's gonna get 3 records. So it's actually a phantom read, and the 3rd phantom is actually Eddard, right? So that's kind of like a special case of non-repeatable read. So it was non-repeatable because we got different set of results. So we actually got an extra record here in the same transaction. So look at that, guys. We got all of them that read uncommitted. Okay, but at least our databases, we didn't have to implement functionality or anything. So maybe people, whoever executes these, whoever implements these read uncommitted, maybe he doesn't care about isolation. So what if I got 4 likes, and if I click on the 4 likes button, I get actually 3 results. You see it in Instagram all the time. Let's face it, right? People don't care. Yeah, okay, 4 likes, but I click and there's 2 records there. So that tells me that Instagram actually doesn't care about isolation. Yeah, it's just like it's just an overhead in general that is not worth implementing, unlike other solutions. Sometimes you, as an engineer, you have to make these decisions and says, yeah, maybe I'll go with read and commit. And I'm gonna talk about that more and more. Okay, so you have to really make decisions into the smallest thing, and you can gain a lot of performance. Sometimes there's, oh, I cannot afford that. I need to be fully consistent. I need to be fully isolated. All right. So yeah, guys. All right. I hope you enjoyed this. I'm gonna see you in the next one where we actually talk about read committed uh, isolation approach. Stay awesome. Goodbye.